Hello everyone, thank you very much for signing into my live stream. I'm Mr. Matt and this is Dr. Tot. Oh, dropped your cookie, Tot. And welcome to Algebra 2. Today we're going to talk about factoring. There's two different versions of factoring the standard way. One is when the leading coefficient in the standard form of the quadratic equation, which is ax squared plus bx plus c is equal to 0. That's the standard form. When a is equal to 1, factoring is a little bit more straightforward, and but when a is not equal to 1, there's some extra considerations that we need to take when we're splitting that quadratic into two product binomials, or the product of two binomials. So we're going to get some exposure to that today. Let me go ahead and share my screen with you. And as always, because this is a live stream, there is a little bit of a delay between the iPad, so I appreciate your understanding. I'll keep track of the live stream, though, to make sure everything lines up. And as always, as well, if you find these videos helpful, then please like the stream and subscribe to my channel. I appreciate it very much. Okay, the overarching theme. So factoring is analogous to division, and foiling is analogous to multiplication. In other words, factoring is similar to division, and multiplication and foiling is similar to multiplication. So you can think about them as opposite operations. It's just that we have other factors that we have to distribute within the parentheses, so it's not just straight applying, or it's not just a straight scalar multiplication. There are some extra considerations that we need to make when we take the product or take a quadratic into two products. So they're opposite operations, and they can be used to check your answer. So when you factor appropriately, it should FOIL back into the answer that you originally were asked about, or the quadratic you originally had. So you can kind of undo your process to make sure that the process you originally did was correct. That also takes us up to the standard form of a quadratic formula, quadratic equation. But the quadratic formula is different than this. The standard form of a quadratic equation comes in the form of ax squared plus bx plus c is equal to 0, where a is the leading coefficient, and it's the coefficient that's next to the squared variable. The variable doesn't have to be x. It can be any letter, but they all have to be the same letter. And the leading coefficient is always the one next to the x, or the variable squared. They can be rearranged, but remember that addition is commutative, so order doesn't matter with addition. So you can always reorder them so that the leading coefficient, the a value, does come first in the actual quadratic, and so you can most easily identify it. So here you're just going to take literally the leading coefficient. Remember that if it has no coefficient, it's implied to be 1. So let me solve the first question here for you, or with you, and then I'll give you some time to look at question 2 and the other problems as well. So here, list the values of a, b, and c in the following quadratic equations. Number 1 says x squared plus 3x plus 2 is equal to 0. So again, when there is no coefficient, it's implied to be 1. So in this quadratic, a is equal to 1, b is equal to 3, and c is equal to 2. I'm going to give you 2 minutes. I'd like you to complete question number 2. That quadratic reads 3x squared plus 5x minus 4 is equal to 0. So for the quadratic 3x squared plus 5x minus 4 is equal to 0, a here would be positive 3, b would be positive 5, and c would be negative 4. If the value has a subtraction sign, then you need to take the negative when identifying the leading coefficient. So c here is negative 4, not positive 4. If you have any questions, then please let me know. Otherwise, I'm going to give you 3 minutes. Please look at 3 and 4. Okay, so for number 3, a would be equal to positive 2, b would be equal to negative 7, and c would be equal to positive 8. Remember that if there's a subtraction sign, that you have to make sure that you take the negative. For number 4, a would be equal to 10, b would be equal to negative 15, and c would be equal to negative 20. If you have any questions, then please let me know. Make sure that you took the negative with that b value, negative 15, and the negative with the c value, negative 20. If not, let's go ahead and look at factoring. Let's see if I can make this larger. So, with factoring, first we're going to talk about when a is equal to 1. So the rule here is that you write out 2 sets of parentheses and break the first squared variable into two variables to the first power, the power of 1, in the left position of each parentheses. And you can see that's what is going on here. So when we have a standard form where the leading coefficient is x, or excuse me, the leading coefficient is 1, and remember, if there's a leading coefficient of 1, it's implied. We usually don't write it out. So if it's x squared, the x gets positioned into the first left-hand spot in the parentheses, and then we're going to consider, going back to the rule here, we're going to look for two factors of c that add together to get the b value, and then distribute those factors in the right position of each parentheses, and we can always use foiling to check that we did the appropriate process. So you can see that we take the quadratic, we split it into two parentheses, assigning the first order x into the left side position, and then we're going to consider the factors of c that add together to get b in the right factor position, or in the right position of the parentheses. So let's look at some examples here, and I'll solve this one with you. Problem number 1 asks you to factor the following quadratic equations, which is, the first one is x squared plus 5x plus 6 is equal to 0. So the first step is to just draw out your set of parentheses. And this x, the leading x, is going to take the first position in each of the parentheses. So I'm going to assign x and x in the first positions. Now I'm looking for two factors of my c value that add together to get my b value. So in other words, I'm looking for two factors of 6 that add together to get 5. Notice that we have 1 and 6. The factors of 6 are 1 and 6, 2 and 3. So here, this one's a little bit tricky because you can see that 1 and 6 and 2 and 3 can both add or subtract together to get 5. 6 minus 1 is 5, and 2 plus 3 is also 5. However, there's only one set of factors that can multiply together to get positive 6 and add together to get positive 5. 1 and 6 have to be different signs because 6 has to be taken, 1 has to be taken away from 6 to equal 5. But 2 and 3 can sum together. 2 and 3 can also multiply together to get 6. So they can sum together to get positive 5, and they can multiply together to get positive 6. So I'm going to assign plus 2 and plus 3. So the factored form of x squared plus 5x plus 6 is x plus 2 quantity times x plus 3. I didn't ask you to solve here, but this allows you to then use the principle of zero products, which tells us that whenever we have two products, meaning we have two things times each other or multiplying into each other, if they're set equal to 0, then we could, if we wanted to solve, set each one of these products equal to 0 and solve for x. So in this example, x would be equal to -2 and x would be equal to -3. I didn't ask you to solve, but I just wanted to give you that information. But when a is equal to 1, when there's when the leading coefficient of the entire standard form equation is 1, you're just looking for two factors of c that add together to get b. If there are any questions, then please let me know. Otherwise, I'm going to give you 3 minutes. Please look at question number 2. Okay, so looking at this problem, x squared plus 7x plus 10 is equal to 0. First, start off by setting up your set of parentheses, and then we're going to distribute that x into the first position. Then we need to find two factors of 10 that add together to get 7. So 10 has factors of 1 and 10, 2 and 5. Notice the systematic way that I'm listing out the factors here. If you do it in this manner, start with 1 in the numbers go up on the left and the numbers go down on the right. And it gets to a position at the end where there's only a select number of integers in between those last factors. So notice the only numbers in between 2 and 5 are 3 and 4. If you check to make sure that 10 isn't divisible by either 3 or 4, then once you get to that situation, you know that you've exhausted the list of factors for that particular value. Now that seems a little bit unnecessary for such a small factor or such a small value like 10, but if you had a larger number like 240, that's going to have a lot of factors in it, and so you don't just want to shoot in the dark and guess at one number and just hope that you have all of the values, because you could miss out one and that could be the pair that you need. So if you go up on the left, you go down on the right, and they'll meet in the middle, and you only need to check the values in between to make sure that you have all factors considered. So here, notice that 2 plus 5 will give you 7. So I'm going to say x plus 2, x plus 5. Oops, sorry. And also remember that we could FOIL here to check that we did this correctly. First times first would be x times x. Outer times outer would be x times 5. Inner times inner would be 2 times x. And last times last would be 2 times 5. That would give us x squared plus 5x plus 2x plus 10, which simplifies into x squared plus 7x plus 10. Notice that that is what we started with, so we know that we factored here correctly. Remember that foiling is the opposite of factoring, so you can always FOIL out to make sure that you did the process correctly. If I asked you to solve, then we could use the principle of zero products here and set each of these factors equal to 0. So I could say that x plus 2 must equal 0, and I could say that x plus 5 must equal 0. Therefore, x would be equal to -2, and x would be equal to -5. I didn't ask you to solve, but that's just for your own information. If you have any questions, then please let me know. Otherwise, I'll give you 3 minutes. Please take a look at question number 3. Okay, so for question number 3, we have x squared plus x minus 6 is equal to 0. So start off by just setting up your two parentheses. We're going to distribute that x squared into 2. We're going to split that x squared into two x's to the first power located in the first position of each parenthesis. And then we're looking for two factors of 6 that add together to get positive 1. The factors of 6 are 1 and 6, 2 and 3. Here's a little clue. If your C value is negative, your factors are going to have opposite signs. And the larger value will have the sign of your B value, because you need the larger value to overtake the smaller value sign and remain whichever sign that you intend it to be. So notice that 2 and 3 can be combined together in such a way to get negative 6, or it can be multiplied in such a way to get negative 6, and to add in such a way to get positive 3. Excuse me, positive 1, not positive 3, excuse me. And notice that that would be positive 3 and negative 2, because negative 2 and a positive 3 will give you a positive 1 if you add them. If you multiply negative 2 and positive 3, that will give you a negative 6. So that checks out here. If we were to FOIL, we would get x squared plus 3x minus 2x minus 6 is equal to 0. 3x minus 2x is just x. So notice we do get back what we originally started with, x squared plus x minus 6. So this is correct. And if we wanted to solve, we would just set these guys equal to 0. And so x would be equal to negative 3, or x would be equal to positive 2 if I asked you to solve. If you have any questions, then please let me know. Let's do one more, and then we're going to look at when a is not equal to 1. So I'll give you 3 minutes. Okay, so if x squared minus 6x plus 8 is equal to 0, then I'm going to write out my factor pair parentheses and assign x to be in the first position of each of the parentheses. And now I'm looking for two factors of 8 that add together to get negative 6, but multiply together to get positive 8. So the factors of 8 are 1 and 8, 2 and 4. Notice that a negative 2 plus a negative 4 will give you a negative 6, and a negative 2 times a negative 4 will give you a positive 8. So those work out, and if we were to FOIL, we would get x squared minus 2x minus 4x plus 8. 2x minus 4x is a minus 6x, and so we do in fact get back with what we started with. And if we were asked to solve, then we could say that x minus 2 is equal to 0 and x minus 4 is equal to 0. That's of course because the products were set equal to 0. If they're not set equal to 0, then you can't do that. This is called the principle of zero products because the products have to be set equal to 0. And so you could add 2, so x would be equal to positive 2, and you could add 4, so x would be equal to positive 4, if they asked you to solve here. If you have any questions, then let me know. Now, the second way of factoring when a is not equal to 0. This is a little bit more tricky. There's some extra considerations that we have to make. So the rule here is that you start off the same way, write out two sets of parentheses and break the first squared variable into two variables raised to the first power in the left position of each parentheses. The coefficients, however, of these values are factors of the a value. That the factors in the right position can be evenly distributed by, or that the factors in the right position can be evenly divided by, Look for two factors of a times c. So now we're not taking factors of c two factors of c that add together to get b. Now you have to consider the factors of a times c that add together to get b. And distribute the factors in the right position of each set of parentheses. Then the final step is that you have to adjust these factors to work with the coefficients of the a value that are distributed in the left positions. So that sounds like a lot, and it is a little, two extra steps that can be quite confusing to students. But it actually comes a lot easier when we look at some examples. So let's look at number 1. So number 1 says 6x squared plus 17x plus 12 is equal to 0. So now a is not equal to 1. Here a is equal to 6. So we're no longer considering just factors of c. We have to consider factors of a times c. A times c is 6 times 12, and that is 72. So we're considering factors of 72. Again, this is a larger number, so we want to go about this in a systematic way. Start with 1 and 72. 2 goes into 72 36 times. 72 divided by 3 is 24. 72 divided by 4 is 18. It's not divisible by 5 because it doesn't end in 0 or 5. Let's see if it's divisible by 6. It is. 6 goes into 72 12 times. See how the numbers are narrowing together? That means that there's fewer and fewer factors that we need to consider. I doubt that 7 goes into 72. Let's just check it. Nope. 72 divided by 8 is 9. So 8 and 9, notice that these are consecutive values here. There's no integer in between 8 and 9. They're consecutive on a number line. They have a marginal distance of 1. So we know, because we have met consecutive values at the end, we know that we've considered all possible factors of 72. Now we're looking for combinations that would add together to get 17. So let's see here. Oh, I'm sorry, it's staring right at me. So 9 and 7. I'm sorry, I was like, did I do something wrong here? Okay, 9 and 7. I highlighted it, so for some reason I wasn't looking at it. So 9 and 7 work to give us 17 if we add them together. Now, what we have to do is we have to also consider the factors of a. A is equal to 6, so our factors are 1 and 6, 2 and 3. What I need to do is, and this is a little bit of guess and check, it's not like a science to this, and this is what can be frustrating to a lot of students. Notice how 1 and 6 don't match up as factors of 8 and 9, the values that I chose for the A times C value. But notice that 2 and 3 both are divisors of 8 and 9, respectively. 8 can be divisible by 2, and 9 can be evenly divisible by 3. That's a clue that those are the values that I need to work with. So instead of, I'm going to start by writing out my binomial pairs, but now instead of assigning just x to the first position, I need to assign 2x and 3x, the factors of 6x squared, in order to reproduce that x squared coefficient, or the coefficient that's attached to the x squared, once I FOIL. So notice that 2x times 3x is in fact 6x squared. Now, when I align these factors, however, I need to take that into consideration. Notice that the inner value here, the 3x is going to affect that other inner value when I multiply. And similarly, this 2x and whatever value goes here, they're going to affect each other because that's the outer times the outer value. That's going to combine with the inner times the inner value when we FOIL. So what you have to do is an extra consideration. You have to take your factor and line it up with the divisible value. So I know 9 goes with 3 and 8 has to go with 2. And you need to divide by the number that is now going to affect that value. So you have to kind of massage the numbers a little bit. We needed a positive 9 and a positive 8, but we have those leading coefficients that are going to ultimately affect this value. So we have to manipulate it a little bit so it works out. So now we're going to have 2x plus 3 times 3x plus 4 when we simplify. And notice we could check this by FOILing. First times first would be 2x times 3x. Outer times outer would be 2x times 4. Inner times inner would be 3 times 3x. And last times last would be 3 times 4. Notice 2x times 3x is 6x squared. 2x times 4 is 8x. 3 times 3x is 9x. 3 times 4 is 12. And that will simplify back into the quadratic that we originally started with, which is 6x squared plus 17x plus 12. So that is what we started with way up here. So this is our answer in factored form. The trickiest part that a lot of students get confused by is this little manipulation that you have to do. Because remember, your A value is no longer 1. So for the outer and the inner values, they're going to be affected by that additional coefficient. So you have to undo that coefficient's effect in the value once you substitute it in. If there's any questions, then please let me know, and we're going to get a lot more practice with this. Let's look at number 2. This will bring us up to the end of class today. However, we'll pick back up on Friday with this, and I'll also be posting a recording for Stream 1 that'll have extra examples as well. So I'll give you 3 minutes, and then I'll give you the solution. After a minute and a half, I'm going to start solving the problem as well. Okay, so looking at this guy, let me just finish simplifying here. Okay, so looking at A times C, A here is 15 and C is negative 6. We're not really concerned about the negative when we're talking about the factors though. So A times C, or the absolute value we could say of A times C, is 15 times 6, which is 90. I listed out the factors of 90 there: 1 and 90, 2 and 45, 3 and 30, 5 and 18, 6 and 15, and 9 and 10. Now we want to add these two factors of 90 together to get positive 1. The only factors that work that way are 9 and 10. So if we had a positive 10 and a negative 9, that would give us a positive 1. And then the factors of A is 15. So we have 1 and 15, 3 and 5. I picked 3 and 5 based on the fact that it works with 9 and 10. Notice that 9 is divisible exactly by 3 and 10 is divisible exactly by 5. 1 and 15 would not work because 15 can't go into 9 nor 10 evenly. So that's a clue here. So then I assigned the first positions from that conclusion. I assigned 3x and 5x. Excuse me. That's in the step before. So that's where I assigned 3x here and 5x here. And then in the right positions, I assigned my factors of 10 and 9, making sure that I place them correctly. The order matters here. I need to make sure that the 10 is going to be affected by the 5 because 10 is evenly divisible by 5. I need to make sure that the 9 is on the outer edge of the problem because it needs to be affected by the 3, because 9 is only divisible by 3 in this problem. It's not divisible by 5. So then I adjust the value by dividing by the number it's going to be multiplied by to kind of undo that effect. Otherwise, the factored values would end up being too large when we FOIL out. So 10 divided by 5 is 2. Negative 9 divided by 3 is negative 3. So I get an answer of 3x plus 2, quantity times 5x minus 3. If we were asked to solve here, we could do so by just setting them equal to 0 because the whole thing is equal to 0. So I could say 3x plus 2 is equal to 0 and 5x minus 3 is equal to 0. So subtracting 2, I would get 3x is equal to negative 2. And then I could divide by 3 to find x is equal to negative 2/3. Or I could add 3 on both sides to find 5x is equal to positive 3. And then divide by 5 to find x to be equal to 3/5. So that brings us up to the end of class today. If you have any questions, then please let me know either in the live chat feed or in the comment section below. I'm here for you guys every Monday, Wednesday, and Friday. Remember that Tuesdays are reading days and Thursdays are writing skills days. And if you have any questions, then I'm available on all of my social media. If you have any recommendations for videos, I'm very open-minded towards that as well. Or if you have any questions just about homework or a project, please just let me know. Otherwise, I hope you guys have a wonderful night. And Dr. Tot, do you want to say goodbye to everybody? You've been very sleepy today. Come on, you guys say goodbye to everybody. That's your job. Come on. He's very tired. You say goodbye? Can you say bye? Oh, good boy. Very good boy, Dr. Tot. All right, thank you guys very much for watching. I'll talk to you all on Wednesday.